Good afternoon. Welcome to this hearing. Thank you to each of the witnesses for being here. On December 14th, 1972, before returning home, Apollo astronaut Gene Cernan took the last steps on the lunar surface and stated, "As I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just say what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon at Taurus Littrow, we leave as we came, and God willing, as we shall return, with peace and hope for all mankind." These words are just as true today as they were in 1972. America's challenge during the Apollo era has forged man's destiny. That destiny, I believe, is to put American boots on the surface of Mars. It has been more than 4 decades since Gene Cernan left the lunar surface. NASA is once again looking to return to the moon in the 2020s and will use it in turn as a stepping stone to reach Mars in the 2030s. Even though we've been to the moon before, our return will not be easy. As a generation of engineers and scientists at NASA have since left the workforce, while the moon will provide a great testing ground in preparation for the journey to Mars, we must remain vigilant and ensure that we limit costly delays that could push a crewed Mars mission in the 2030s out of reach. Let me be clear. Mars is today the focal point of our national space program. And if American boots are to be the first to set foot on its surface, it will define a new generation, Generation Mars. In preparation of a crewed mission to Mars, NASA has been sending scientific robotic missions to the 4th planet in our solar system for the past 4 decades. Yet we still have much more to discover. Last month, NASA's Curiosity rover discovered organic compounds, which may be a sign that there was once life on Mars. While the discovery of organic compounds leaves scientists with more and more questions, it also leads us to believe that we may be on the right track. And just today, the journal Science published a report on radar evidence of subglacial liquid water on Mars. Using radar profiles collected from a satellite between May 2012 and December 2015, scientists have found evidence of a 12-mile-wide reservoir of briny water beneath the south polar layered deposits. This and other exciting discoveries deserve to be built upon, explored, and studied to their full potential. That's why we're gathered here today, to build upon the framework that was established in the NASA Transition Authorization Act of 2017, and to make progress in ensuring that our nation's exploration priorities are being met so that we can push humans further than they've ever gone before. Somewhere in a classroom today, in Texas, or Florida, or Massachusetts, sits a child who may one day become the first American to reach the surface of the red planet. It's our responsibility to ensure that we have a national space program that can help turn that dream into a reality. With that, I'll recognize the ranking member of our subcommittee, Senator Markey. Thank you, Senator Nelson. Let me thank Senator Nelson and Senator Markey both for your strong leadership in ensuring and continuing the bipartisan support for NASA and our space exploration mission. I guess I have to apologize to the witnesses that apparently you've been overshadowed by a mystery witness, Matt Damon. And you know, I would note that in his journey to Mars, Mr. Damon demonstrated the ability to grow potatoes in human excrement. And I would note likewise, there is no greater repository of expertise in that biofuels than the United States Congress. So with that...
May I just say that we are the most Irish city in the United States, and we're very good at growing potatoes, okay? Something that we learned in the New World, and to Senator Nelson, I did not use the full accent in talking about the future and leaving behind the past. I decided to use the Malden version of that accent, but nonetheless, the vision of President Kennedy still lives.
With that, I'm happy to introduce our distinguished witnesses today. Our first witness is Dr. Peggy Whitson, who is a retired NASA astronaut and a biochemist. A native of Iowa, Dr. Whitson has had a career at NASA, which includes becoming the first woman to serve as their astronaut corps chief and the first female commander of the International Space Station. Dr. Whitson has completed 3 long-duration missions to the ISS, which include 10 spacewalks, and setting the record for the most time in space by a U.S. astronaut at 665 days. Prior to being selected to serve as an astronaut, Dr. Whitson received her PhD in biochemistry from Rice University, my mother's alma mater, and worked as a research biochemist in the biomedical operations and research branch at NASA's Johnson Space Center. Our second witness is Mr. Tory Bruno, who is the President and Chief Executive for United Launch Alliance, which utilizes the Atlas and Delta rocket families and has achieved more than 120 consecutive launches since 2006. In his role as CEO, Mr. Bruno serves as the principal strategic leader of the organization and oversees all business management and operations while managing a nationwide team of nearly 2,500 employees. Prior to joining ULA, Mr. Bruno served as the Vice President and General Manager of Lockheed Martin Strategic and Missile Defense Systems. Mr. Bruno holds a bachelor's degree in mechanical engineering from the California Polytechnic State University. Our next witness is Mr. Chris Carberry, who is the CEO and co-founder of Explore Mars, Inc., a nonprofit created to advance the goal of sending humans to Mars within the next 2 decades. Prior to joining Explore Mars, Mr. Carberry served as the executive director to the Mars Society. In recent years, Mr. Carberry has led the successful international conferences, including the ISS and Mars Conference in Washington, D.C., and Strasbourg, France. Prior to his space career, Mr. Carberry worked as an archivist of modern political papers and was a research assistant for numerous best-selling biographers. And finally, Dr. David Newman currently serves as the Apollo Program Professor for Aeronautics and Astronautics at the Harvard-MIT Division of Health Sciences and Technology. Dr. Newman's research includes advanced spacesuit design, dynamics and control of astronaut motion, mission analysis, and engineer systems design and policy analysis. From May 2015 to January 2017, Dr. Newman served as the Deputy Administrator of NASA. In her role as Deputy Administrator, Dr. Newman was responsible for providing overall leadership, planning, and policy direction for NASA. Dr. Newman received her PhD from MIT in aerospace biomedical engineering. And with that, Dr. Whitson, you may begin. Thank you very much, and thank you to each of you, the witnesses, for your testimony. Let me start out with a question to the panel. Why Mars? Why should the American people care if we put a human being on the surface of Mars?
Well, I think we have a lot to learn about life and how it might happen and occur in other places. And I think one key aspect of exploration, if you look at the philosophical part of exploration, is learning about life and where we've come from. But I think, you know, the big thing that benefits of exploration maybe are not so much those philosophical ones, even though that's what drives some of us. I think it's the technological advancements. Doing these difficult things is going to improve our capability as a country, as a nation, as a world on solving problems here on Earth. And increasing technology, having people interested in the sciences, studying more and learning more things in the sciences is going to be a benefit here on Earth.
I agree with everything my colleague has said. I'd just like to add that when you want to establish a fundamental scientific understanding of a complex system like our own planet, it is crucial to be able to study similar, in this case, celestial bodies in a different state of their evolution. And Mars uniquely offers us that opportunity to have more than one data point in a different state than our own planet is in today.
It's interesting. My organization actually has a whole program on this very question. We released a document about a year ago where we had about a dozen different individuals from different disciplines. We had Hollywood actors, we had scientists, we had science fiction writers, all and STEM educators, just every imaginable discipline, explaining why we did. And this is one of the biggest questions, why I think the whole space community sometimes doesn't answer the question well, because there are so many good answers. When we went to the moon, really there was one primary answer: to beat the Soviet Union. It was easy to articulate, let's beat the Soviets. Today, we have so many more and so many better reasons. The inspirational value. If you go around speaking to kids around the country, you realize they're really inspired. The technologies that will be required for it. Plus, of all the places that humans can go in the solar system, Mars is best suited for humanity. As the discoveries today of the liquid water below the surface of Mars will show, we can live off the land on Mars. While there are resources on the moon, they're not nearly as, abundant, and there's no atmosphere there. So Mars is really the best option for sending humans for sustainability that we can achieve anytime in the near future.
Agree with all my colleagues. But Mars and Earth, 4.5 billion years old each, sister planets. So Mars was probably habitable, warm, wonderful. And then probably 3.5 billion years ago, something went terribly wrong. Why is that so important? It teaches us about Earth because it teaches us about life. So it's a fundamental question about life. And we follow the water. So we're going to follow that water we just found today right down into the subsurface. Because you look for those amino acids. Those amino acids have been spewed all over by comet sensors. They're all over the universe. So we're looking for life. So the search for life has been mentioned. It's the closest, not too close, closest place to go, best place to go. We will find this answer about life, other places, past or present in the universe. That will fundamentally rewrite all of our scientific textbooks. And I just can't think of anything better to do.
In your judgment, what are the biggest scientific and technical hurdles that stand between us and landing safely on Mars? And are we on trajectory to clear those hurdles and get to Mars and back safely by the 2030s?
So I'll go first. From a rocket scientist point of view, it's actually very difficult to go to Mars. And I place those challenges sort of into two buckets. One is simply the trip. The orbital mechanics of traveling to Mars is a challenge. The other are the human factors, or the safety aspects of going to Mars, because it is a very long, deep space transit. So if I start with the first aspect, just to give you a feel for it, our two planets are always in relative motion. And the geometry of the Mars orbit is especially challenging because not only is Mars going around the sun at only half the rate that the Earth is, it's also a very eccentric orbit. It's highly elliptical. And so the distance between our two planets can be as small as a gigantic 35 million miles or as large as 250 million miles. And the only times we can really practically go to Mars is when the Earth is catching up and about to surpass Mars And at that point, that's really our only launch window, where we send a spacecraft to sort of tangentially drift off and later intercept with the Martian orbit and then do that rendezvous. Those opportunities only come around once every 2 years because of the relative motions of our planets. The orbital accuracy required to achieve that defies sort of human imagination. It's hard to relate to what we truly have to achieve. So I did a little quick math last night to try and scale all that down so it would fit on the Earth so that we could sort of relate to it a little bit better. And the way it works out is if we place this on Earth, scaled down, it's much like hitting a hole-in-one, for those of you who are golfers, out at California's beautiful Pebble Beach, teeing off from Paris while standing on a moving pickup truck. That's a pretty difficult problem. You're sending this spacecraft on a fixed trajectory to travel as much as 300 million miles way back at Earth. That's when you let it go and it heads off. So the orbital mechanics piece is very, very difficult. The next challenge we run into is the transit time in the environments that our Mars astronauts will be exposed to. Because this is deep space travel, they will be experiencing radiation environments that are 4 times more severe than what we see on the International Space Station, which is largely still protected by the Earth's magnetosphere. Because of the extreme duration of the mission, now we can get to Mars on the right 2-year cycle, theoretically as fast as 3 months. But most practical missions are really going to take more like 6 to 8 months. So because of that duration, our astronauts that go to Mars and conduct a mission and come back are going to see at least 100 times, probably more than 100 times, the total radiation exposure that Apollo astronauts experienced going to and from the moon. And so it's going to be absolutely vital that we developed ultra-lightweight shielding materials and procedures and CONOPS that will minimize the exposure of our astronauts to that environment. We know only some of the health effects associated with that kind of radiation exposure, and if they're not protected, they're pretty scary. We understand there will be significantly increased risk of cancer, the potential for nerve damage, cognitive impairment, and even cataracts. And so we cannot tolerate that. We have to keep our astronauts safe and within reasonable risk limits on that trip, which is also why I believe the moon, in a way, is on the way to Mars, because it affords us a platform to do that research, develop these technologies, qualify them nearer to home, 3 to 6 days from home, before we commit that trip that's going to take at least a year.
Well, and let me echo something Mr. Bruno said in terms of talking about the opportunities of commercial space. One of the reasons we've seen some of the advances we've seen in recent years is because of the very beneficial collaboration we've had between the public sector and NASA and the commercial space industry. And at the end of the day, the commercial sector is going to be able to invest billions more in dollars to getting this job done. And I share your optimism about the potential, and indeed I've predicted before that I think the first trillionaire that we see will be made in space. I don't know who it will be, and I don't know what they will discover or what they will accomplish, but I think it is every bit as vast and promising a frontier as the New World was some centuries ago. One of the things that's been gratifying in this time of deep partisan division on so many issues is that space has not been one of them. That we've seen under President Obama, we've seen under President Trump, a cooperation in the Senate, in Congress, between Democrats and Republicans, committed to maintaining space exploration and America's leadership. In the past several years, we've passed bipartisan legislation authorizing NASA, commercial space launch legislation, one signed by Obama, one signed by Trump. We're in the process of taking up, and I hope passing, yet a second round of commercial space launch legislation that I just recently introduced. And the intention is to take up a longer-term NASA authorization bill. The one we passed last year was the first one in 7 years. It was an important milestone, but it was designed to ensure continuity. This next NASA authorization, the hope is that it will reach further and be bolder in aspirations. And so I guess the question that I would ask this panel is, if the objective, as all seem to agree, is getting to Mars and getting to Mars by the 2030s, are there elements that any of you think are particularly important for Congress to include in the NASA authorization legislation to facilitate that, to accelerate that, to remove barriers that may stand between us and getting to Mars?
I would say two things, and one of them you have already alluded to, sir, which is stability in the national goals and the funding associated with that, so that there are not fits and stops and starts and loss of vital workforce, as I alluded to a moment ago. The other thing that I think we need to be mindful of, I mentioned in my opening remarks, from the standpoint of the launch industry, this is a flat marketplace. If anything, expected to have a temporary dip. It's essential that we have a healthy industrial base. The thing that is unique about our system in America is that we have a partnership between government and industry. NASA and its industry partners work together. That's why we have the greatest technology in the world. It's why we can aspire to tremendous goals like putting boots on the Mars and putting a permanent presence there. The industrial base must be taken care of. And so at a time when the other commercial demands for launch, for example, are low, then we need to make sure that we have a healthy, competitive set of companies in America, and we do that by keeping those investments at home in our own industry.
One of the critical things I think is actually needed is something we've gone over in one of our previous workshops, brought aerospace professionals together, and we created, kind of outlined probably about a dozen long pole technologies. These are technologies we need to start working on pretty much immediately if we have any hope of landing humans on Mars in the 2030s. These include entry, descent, and landing, as Dr. Newman mentioned, and other things like ECLIS, ascent. Some of these technologies are going to take quite a while to actually achieve, and if we can't just wait until we're at Mars and then say, oh, now we have to figure out how to land. So we have to start working on them now. We have to outline which ones, plus outline which ones have direct overlap with lunar exploration. First, defining what lunar exploration means in the context of what we're going to do, but then figure out which ones have direct overlap, so we can actually start working on those specifically. Another thing I think, which was already actually mentioned in the 2017 authorization, better integration with the mission directorates and the partners to make sure they can move ahead efficiently. So like human exploration and science and technology can all work in tandem, towards that one goal. So there are probably dozens of other things I can mention, but I'll leave it right there. Thank you.
Yes, constancy of purpose. We like to call that advanced propulsion, smart habitats, incorporating all of that autonomy that is, we're on the edge of right now. Entry, descent, and landing. Bioregenerative life support systems hasn't been mentioned. Suits, in situ resource utilization. That's what we do when we get to other planets. That's what explorers always do. We live off the land, so we have to figure that out. We have to make the habitats out of our basalts. When it comes to humans, radiation is the number one. We need to work on that more. But the human factors, the mental well-being of folks far, far away, we can't trivialize that. Really need to take care of the safety and wellness of our astronauts. Musculoskeletal, we're getting a handle on that. And this, I just back my final comment, is this integration, that just doesn't, that's really functional. That's really the functional organization that's hard, because we can't have the stovepipe, so we really need science, technology, human exploration, one pot of money. So that's why I call the Mars Program Office. That would be the true integration. I think we could get there.
If I could add one more thought to one of the things that David brought up. I hear a lot of debate and assertions in this question that, well, this is a great human endeavor and there's going to be risks, and so we're just, we're going to tolerate people being lost. And it is true that there are inherent risks in going to space. Space is a physics-defying act, and it is not possible to make it risk-free. That's a fact. However, there is no reason that we need to take unnecessary risks with human life. Our astronauts are sons and daughters, mothers and fathers, husbands and wives, and it is not acceptable that we take risks with their lives and well-being that we can avoid and apply our ingenuity and our industrial and technological might in order to mitigate.
Well, I will go back and just reiterate that the one most important thing is constancy of purpose. We have to have a vision that lasts more than one administration. We have to have a budget line that will support those goals and objectives that we are striving to reach. And to me, I think that will help us solve a lot of the problems.
Well, thank you very much. Let me thank each of the witnesses. I would note on constancy of purpose that has been one area where we have seen wide agreement in Congress and in the Senate. And indeed, we began the NASA authorization endeavor in the previous administration and continued it through to this administration precisely to avoid the sort of cancellations we've seen in the past, whether with Constellation or otherwise, and the billions of wasted dollars and frustrated man-hours that were lost. And so let me thank each of the witnesses. This has been, I think, a very productive and informative hearing. Thank you for your lifelong commitment. This is a labor of love. Nobody is confused that you are doing this for anything other than passion. We will keep this hearing record open for 2 weeks. There may be senators who submit follow-up questions, and the witnesses are asked if there are follow-up questions to promptly respond to those. And with that, this hearing is adjourned.